Hi, I am Lopa Mudrashen. Welcome back to my channel Electronic Science Tutorial. From today I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not check out my channel, please follow my channel. If you like my channel, then please do like, share and subscribe my channel. So let's start our class. In today's class, we discuss about the NTA UGC NET and West Bengal SET exam 2022. In this session, we cover in detail about this topic so that we can easily solve the previous year question paper of UGC NET Electronic Science. Each and every topic we can understand in easy and simple manner. So, let's begin our NTA UGC NET exam 2022 class. Okay. Today I will discuss one most important topic of semiconductor device, that is density of state functions. From the chronic penny model, we know the parabolic relationship between the energy and the momentum of a free electron is E equal to p square by twice m, where E is the energy and p is the momentum. P is replaced by, we can write P as h cut k, which is the crystal momentum of a single crystal. This crystal momentum of a single crystal is not the actual momentum of the electron in the crystal, right? But it is a constant of the motion that includes the crystal interaction. So, we can replace P by h cut k. So, what we get, that is h cut square k square by twice m. So, this is our E versus K curve, where this is the conduction band and this is the valence band. In the conduction band we get electrons and in the valence band we get holes. This is the gap between the conduction band and valence band, and this is the E versus K graph. At K equal to 0, that means at the bottom of the conduction band, we can consider this curve as a parabola. So, how we can represent this equation? That is, the E versus K curve near K equal to 0 at the bottom end of the conduction band can be approximately, it is a parabola. So, how can we write this parabolic equation? That is E equal to EC plus h cut square k square by twice mn star, where EC is the bottom edge of the conduction band, that means this edge is the EC, and mn star is the electron effective mass. So, we can rewrite the equation, that is E minus EC equal to h cut square k square by twice mn star. Okay. So, we can think that the electron in the bottom end of the conduction band is being free electron with its own particular mass. Because of this similarity, the free conduction band electron model we can generate, right? So, the density of allowed electronic energy states in the conduction band is GCE equal to 4 pi 2 mn star 3 by 2 divided by h cube root over E minus EC, and this equation is valid for whenever E greater than equal to EC. That means as the energy of the electron in the conduction band decreases, the number of available quantum states also decreases. Right. So this is the allowed electronic energy state, which is called the density of states in the conduction band. Right. Similarly, the chronic penny model for EK diagram, that is this is the valence band. In previous slide we talk about the conduction band. If we consider the valence band, so the density of quantum states in the valence band, by using the same model, we consider here holes in the semiconductor crystal, which is known as free particle. The effective mass of the hole is mp star. So from the E versus K curve near K equal to 0 at the top of the valence band, we get the approximately the parabolic equation, which is equal to E equal to EV minus h cut square K square by 2p to mp star, where mp star is the effective mass of hole, which is the valency energy in the reduced K space. Right. So we may approximately from E versus K curve we get this parabolic equation. We can rewrite this equation, that is EV minus E equal to h cut square K square by 2 mp star. Right. So this is for free hole. We get this parabolic equation. Okay. So the density of allowed electronic energy states in the valence band for free hole particle, that is GVE equal to 4 by 2 mp star 3 by 2 divided by h cube root over EV minus E. And this equation is valid for when E less than equal to EV. And this is the plot of density of energy states in the conduction band and the density of energy states in the valence band. This side is called GCE and this side is called GVE. This is valid for EV less than E less than EC. So this is the plot of density of quantum states as a function of energy. If the electron and hole effective mass were equal, then the function GCE and GVE would be symmetrical about the energy midway between EC and EV, or the mid gap energy, that is E mid gap energy. Right. So this is the basic concept of density of electronic energy state in the conduction band and the valence band. So here we end today's session. I hope you understand this concept. Thank you. Thank you. I hope you love this informative session of NTA UGC NET or West Bengal SET exam. If you like my video, then please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.